Okay. Adhesives. Next slide. What are adhesives? An adhesive is a substance used for sticking objects or materials together. They have been used by man and in nature for thousands of years. The earliest known use of adhesives dates back to 70,000 BC. Cavemen in South Africa would combine tree sap and red ochre as a way to protect cave paintings. Adhesives have many classifications. However, for the purpose of this assignment, we will discuss the nature of synthetic and natural adhesives. Adhesives are quite literally the glue that holds the world together, and their intricate design and many uses will be the center of our presentation today. Next slide. Natural adhesives are made of naturally occurring products such as vegetable starches, animal products, and cellulose. They are a low cost and renewable source of glue and are often non-toxic. Natural adhesives are often very sticky, and this allows the glue to withstand stresses with its shear properties. They also have the ability to bond with a wide range of materials, giving it a greater appeal. Next slide. Although natural adhesives have increased tack, their hold is oftentimes weaker than synthetic adhesives, especially since the adhesive should be applied to both surfaces. While they are reliable, they also don't last as long as a synthetic adhesive would. Next slide. How do they work? The chemical responsible for adhesive properties in animal glue is collagen. Collagen is the structural protein in animals. It is a long fibrous polymer molecule that is made up of amino acids. Amino acids contain monomeric units that are linked together covalently with peptide bonds. The most common monomeric unit formed by the amino acid is the carboxyl or organic acid. If you can see the structure of the amino acid to your right, it contains an R group, which represents a variety of atoms that can attach to the basic structure. This would vary the structure of the amino acid, which would cause differentiation in the carboxyl and amine group, which is what gives protein glues their adhesive properties. On the model of the protein chain, the backbone of the chain shows the interactive groups. That's on the left side. The NH in the chains has a weak positive charge, while the O groups have a weak negative charge. If these groups get close enough to each other, they will come together to form a hydrogen bond. These hydrogen bonds produce strong cohesive and adhesive forces between the molecules, which is why animal glues can function as adhesives. Next slide.
Casein glue is an adhesive made from milk protein, and it's resistant to water and can also be strong over long periods of time. It's usually made of lime, water, and skimmed milk. Some other facts about casein glue is that it was used by the ancient Egyptians. It's also used a lot in woodworking, and it was used to assemble the early World War II wooden fighter aircraft. It starts as skim milk, and then you let the milk sour to form curds, and then once the curds form, you can grind them into a powder. And you mix this powder with the other ingredients to make the strong glue. And you always mix it with water, and then if you mix it with baking soda, the glue will last longer and be more durable. But if you mix it with lime instead of baking soda, the glue is going to be water resistant, but it might not last as long. There's also vegetable glue, which is made of natural polymers that come from roots and seeds of plants. And these plants could be tapioca, corn, potatoes, rice, or wheat. So it's a good natural glue to use. It's also a common vegetable glue is wheat paste, which is just as strong as white glue. And it's just 1 part wheat flour and 4 parts water. So you can bring this to a boil, or you can microwave it. And then once it's ready, you can just use it right as a glue. And you can also add salt, cinnamon, or vinegar to increase its shelf life. Synthetic adhesives.
What is synthetic adhesive? Synthetic adhesives is manufactured, produced, and modified by man. Based on synthetic adhesives, they're based off of resins and rubbers. It's invented by Alex Carlson. Alex Carlson worked in cinema making film. He needed to fix his shoe sole, so he created glue from melted celluloid-based film resides. He also started a company called Carlson's Klister from out of Sweden in 1922. Next slide. Categories of synthetic adhesives are thermoplastic and thermoset. Thermoplastics is bonded by stress, and thermoset is bonded by crosslink. Next slide. Thermoplastics, held together by intermolecular forces, hydrogen bonding most common. Strong and durable at normal temperature, heat can soften. Resistant to oils, but poor resistance to water. Can be modified and has an unlimited shelf life without any degradation. Next slide. Thermosets, held together by crosslinks for covalent bonding. More permanent, but have a limited shelf life. Once it's molded and hardened, it can't be reshaped or recycled. It's resistant to heat, and heat won't affect the adhesive, but it can't be modified with any degradation of the adhesive. Next slide. Types of synthetic adhesives. Contact cements, which is a thermoset. It's based on solvent solutions of neoprene or rubber. Example is Elmer's glue. Structural, it's another thermoset. It's load carrying or coats. It's long-term and heat resistant. Good example is epoxies and silicone sealants. Next slide. There's also hot melt, which is a thermoplastic. It's a solid at room temperature, but once it's heated, it becomes a liquid. Most common example is the hot glue gun. And then there's pressure fatigue, which is another thermoplastic, requires pressure to bond, and it's done at room temperature. Examples are scotch, packing, and electrical tape. Next slide.
Many synthetic adhesives need a curing method to bond. First is a heat-activated curing adhesives. This consists of a ready mixture of two components. Next is a light UV-activated curing adhesives. Light-activated adhesives are cured under a visible or UV light of appropriate wavelength. Adhesives of this type usually contain photoinitiators enhancing curing reaction. Next slide. Dental bond is a type of synthetic adhesive that needs a curing method through a UV light to chemically bond a retention. The bond creates a true adhesion between the molecules of the composite resin and bonding agent. The image shown on the right represents a representation of how the chemical reaction occurs between the adhesion and the resin. Next slide. In this short video that I've made, I will show you how dental bond adheres to the composite resin. So to begin, we put the dental bond onto a piece of paper. This is in a liquid form, and once we use the UV light that causes the curing motion, it will become hard. Once we have done that, we can go ahead and apply the composite resin. And you can see that in this as well is in a liquid state. So it's not adhering. Once we use the UV light to cure it, it is now creating a retention between the bond, whatever you bond it to, and the composite resin. As shown, it will not come off. That's all.